sequences, series, and progression. Series, sequences, and progression. Do you recognize these words? What is meant by sequence? Does anybody has idea? Himanshu, Shaisha?
So sequence is basically a group of numbers which are arranged by following a certain rule.
Exactly. So they are arranged. So the sequence consists of numbers. Okay. So I have like number 1, 2, 3, 4. Okay. This is the easiest sequence I can think of for the moment. And you know, it has a kind of a definite rule that the next term is incremented by 1, and this is following a definite order. Okay, so they follow a definite order. All right. Now, since they follow definite orders, they look very interesting. Okay. And now, what is the series? What is meant by series? Does anybody has idea?
So when these numbers are joined with positive or negative sign, so they, like sequences is converted into series.
Yeah, for example, we make sum of these numbers. Okay, so then this is a series and so forth. Okay, is a series. Fantastic. We understand progression is just, you know, for sequence. Okay, for sequence, if we can write, an explicit formula. So if we can write explicit formula for, you know, a given term, that implies that it is a progression. Okay. So now we are familiar with these kind of terms. So let's try to understand what are the main topics that are part of this chapter. So what we are going to study is about arithmetic. Progression. We are going to study geometric progression. So sorry, we are going to, yeah. And then we are going to study harmonic. Okay, so are you all familiar with these terms? What is arithmetic progression?
Yes, sir.
So tell me.
Sir, in arithmetic progression, as I told you earlier, that basically it is a sequence in which the terms are related to its predecessor and successor.
Indeed, by a factor that is either, you know, the difference. Okay. So suppose you know nth term an minus 1 is going to be related to d. Okay, d is called the difference. Okay, and these are the terms. Okay, so if there is a finite difference, we say these are in arithmetic progression. Okay, so the next term is geometric progression. What is geometric? So in geometric, what happens is, suppose you have a n term and the predecessor or the later term, if you take any two terms ratio, you will get a fixed factor r. Okay, a factor. Okay, this could be number, it could be ratio, it could be something. Okay, so when you have difference, you say it's arithmetic progression. When you have ratios in the terms of a sequence, you say it is a geometric progression. Now we will learn harmonic. Harmonic, have you heard word harmonic? Harmonic has something to do with sound. So
Yes,
if
sir.
you see any instrument, for example, flute, guitar, or anything, its frequency follows the harmonic progression. Okay, so the frequency of all musical instruments follow harmonic progression. So as you go to higher frequencies, you will get some kind of progression. So that's why there is harmonic progression. Harmonic progression is basically, if you take the nth term, if you do 1 by an minus 1 by an minus 1, then you will get a difference. Okay, so basically harmonic progression involves a sequence. If you take the inverse of the terms of the nearest neighbor terms, they will have a fixed difference. So they will become arithmetic. They will be in arithmetic progression. So series can be of two kinds. First, the finite. Okay, so you have some finite terms. Okay, from A1 to A2, and then you have some AN terms. Sometimes the series can also be infinite. Okay, so sorry, there is some problem. So this thing is visible. Okay, sometimes the series can be infinite, such that you have A1, then A2, A3, and it goes to indefinite number of terms. Okay, then infinite series are also of two kinds. Okay, so for example, if you have a sum where the nth term is less than n minus 1th term, a lot of times its sum is going to be something finite. Okay, I'm discussing a point that infinite series can also have finite sums. Okay, in this case, we say, this, if this property is there, the series can be summed up. Okay, if there is a progression, that is, there is an explicit formula. Okay, the nth term is smaller than the previous term, and if this series goes to infinity, it's possible to have a finite sum. Okay. Okay, but sometimes this infinite series can also have, the sum is not finite. Okay, so they can have two kinds. So if the nth term is less than the previous term, there will be finite sum of infinite series. Okay, finite series will always have a finite sum. Right, this is clear to all of you?
Yes, sir.
Okay,
Yes, sir.
for some basics, later we will see some of these examples, and with experience you will have a look at the series and you will say, okay, this is possible to sum. you will see the series and you say, okay, this is going to be infinite. Okay, so we'll see them later in example. Okay, let's now progress to some simple progressions. Okay, let's move to something called arithmetic progression. Okay, I'm going to repeat some of the concepts of your class 10 because you know that's absolutely needed. So for example, I give you a simplest sequence. You have 1, 2, 3, 4, and so forth. You have this sequence. If I ask you, you know, how can you write nth term? You'll say nth term is just n. Okay, so there is something called nth term. Okay, or sometimes it is written rth term. Okay, we take rth term, some term between 1 and n. If you want to define a term, say rth term, you'll say, okay, our rth term is like this. Right? Do you know some of this kind of series? So if you have such kind of series, suppose its sum is Sn, okay, is 1 plus 2 plus 3, okay, and is going on till n. Now what I'm going to do is I'm going to write the same Sn in inverse order. Till the last term. Okay, now I'm going to sum them up. Okay, so I'm going to sum this term, so this becomes n plus 1. First term becomes n plus 1. Left hand side becomes 2Sn, right?
Yes,
And
sir.
then if you look at each term, it will become n plus 1. And so on. So this is the easiest logic to remember how to sum this series without doing any complications. How many terms are there? 1, 2, till n. Right? So we can write twice of Sn is equal to n times n plus 1. Right? So we can write our Sn is equal to n into n plus 1 upon 2. Is it true?
Yes, sir.
Okay, fantastic. So this was a very nice way to do the sum. Okay, now let's progress to a general series. Okay, general arithmetic series has a term, you know, like the first term is a, then suppose d is the difference. Okay, then next term will be a plus d. Okay, then the next term will be a plus 2d, and so on. This will be a plus, you see, the second term has d, so a plus n minus 1 into d, right?
Yes, sir.
Okay, fantastic. Now we understand till here. Now what we are going to do is we are going to use our same technique. Okay, I want to sum this series. Okay, so I say this series is S general. Okay, SG. Okay, it is the sum of all these. And then what I'm going to do is I'm going to write the series in inverse order like I did before. So the last term I'm going to put here. Okay, then second last, next, and the last term here will be A. Okay. So I'm going to do the same business, A plus n minus 1. A plus n minus 1 into d. So if I do same business, you know what is going to happen. I'm going to add two series, so it will be 2SG. And then each term will become 2A plus n minus 1 into d. Right? This becomes 2A plus n minus 1 into d. So it is n times. Okay. So I can write this general term sum will be n times a plus n minus 1 into b. Okay, I'm going to give you one more way to remember this formula. Okay, so sum of the series can be the sum of first and sum of the last term times how many elements are there. Okay, number of terms divided by 2. Okay, now we have made some progress. Okay, so let's move on. So you know what is the nth term if somebody asks, okay, what is the rth term of the general arithmetic series? You say a plus r minus 1 into d. If a is the first term and d is the difference. Okay, suppose I have like 1 square plus 2 square plus 3 square and so on. I have n square. Okay, now how are you going to solve this? So let's try to understand how to sum this up. Okay, before I will take a little bit discourse, okay, I want to tell about an interesting triangle. Do you know somebody called Pascal? Have you heard about Pascal's triangle?
Yeah, yes, sir.
You know it? Okay, Pascal is the same person who defined the hydrostatic pressure. Okay, he died at the age of 36 and he did wonderful things in his life. So he found a triangle where he had numbers like this: 1 1 1 1 1 2 2 1 1 2 1 3 3 sorry 2 1 3 1 1 3 1 4 3 3 6 3 1 4, and then you pad it with 1 and 1. Okay, this is called Pascal's triangle. So you start with 1 and then you put 2 times 1, you go here and then you add to this. You go here, you add to this, you get this term. You add this to this, you get the next term, and the series continues. So the next will be 6 4 10, 6 4 10, 4 1 5, and then there is 1. Okay, 4 1 5 and 1. You know this series? Okay, so for example, if you want to find a plus b to the power 2, okay, it becomes a square plus 2ab plus b square. Okay, so you can see the coefficient of a is 1, the coefficient of b 2ab is 2, the coefficient of b square is 1. So you see this line, you can get this formula. Okay, now let's look at the next one, a plus b to the power 3. Okay, so a plus b to the power 3, if you want to find, we will look at this row. Okay, I don't memorize anything. I remember Pascal's triangle. I will make it in my notebook. So I'll get a cube times the first one plus a square b times 3 plus 3ab square plus. So, you know, Pascal's triangle gives you a pattern. You first take 1, then you draw 1 1, and then you add 1 to 1, you get the next term. Then you add 2 to 1, you get the next. 2 to 1, you get the next, and then you pad it with 1 on the both sides. And you can continue and you can generate this kind of triangle, okay? Because this is a triangle, right? Saisha, can you get this?
Yes, sir.
Okay, suppose you have a binomial expression a plus b to the power 1. What it will be? A into 1 plus 1 into b. Okay, so this is the expansion for. Okay, so for example, if you take any general term, I have a plus b, okay, and I want to raise it to power m, right? So the first row is m equal to 0. If you put m equal to 0, you will have only 1, right?
Yes, sir.
If you put m equal to 1, what you will have? You'll have 1 into a, so you have the coefficient 1, which is here, 1 into b, right?
Yes, sir.
Now you go for the power a plus b square. You have 1 into a plus 2 into ab plus 1 into b square. You see this row, this is for m is equal to 2. Okay, so right now I'm interested in m equal to 3. I know, however, this is the expansion, but in case you forget, Pascal's triangle is easy way to get, m is equal to 4, m is equal to 5, and so on. Okay, this business is clear to you?
Yes, sir.
So if your friend asks, do expansion of a plus b to the power, 5, then what you can do is you can quickly make the Pascal triangle. This is m is equal to 4, this is m is equal to 5. Okay, you got all the coefficient 1, 5, 10, 10, 5, 1. Okay, now this story I said, so by general knowledge how things are done. Okay, now let's focus on our main problem. I'm going to use this in this problem, so that's why I discussed it. Okay, it's a handy tool, and you'll find later in permutation and combination, these terms tell you combinations. So the term 1, 4, 6, 3, these, when you learn in future permutation combination, there is something used like m to the power n. Okay, then these terms are related to these terms. Okay, we'll use them in permutation combination. We'll learn about them in binomial.
Binomial theorem.
Exactly. Okay, so then we will understand the meaning and do everything about it. But here, our right now problem is to solve this thing. I take a number n, okay, and I do cube minus n minus 1. Can you write the expansion of this? This is n cube minus n cube it is minus, so it will become plus 1, and this is n square minus 3, and later we will have plus 3n. Okay, this is minus, so this will become plus, and this will become minus. Can you confirm my expression is correct? Can you quickly confirm?
Yes, sir.
So what is the outcome of this? This is 3n square minus 3n plus 1. Okay, this is the outcome of this. Okay, now let's do this business from n is equal to 1 onward. Okay, I put n equal to 1 on the left hand side, I get 1 cube minus 0 cube. On the right hand side, what do I get? 3 1 square minus 3 into 1 plus 1. Okay, now I'm going to do for 2. 2 cube minus 1 cube is equal to 3 into 2 square. Okay, this is minus 3 into 2 plus 1. Right? We can continue like this. Please do this thing in your copy. So at least see first 3 terms. If I do with the third, it's equal to 3.3 square minus 3.3 plus 1. Now, if I continue like this and I do for the nth term, so I did nth term here, right? If I go on like this, my nth term will be this one. Do you all agree with this?
Yes.
Now I am going to sum up this column. Okay, while summing up this column, what I can see a pattern. This cube is crossed by this one by this. Okay, so if I do all of them, what do I get? The 3 cube will be cancelled in the next. Okay, so on the left hand side, I will get n cube. Right? Is it true?
It will be minus n cube.
Sorry. It will be, you know, the last term is here. So this term will be cancelled because we see the last term is cancelled. The before one is safe. Minus 0. If you write this down series, okay, then you go to.
Yes, sir. Yes, sir. I got it.
Okay, this is what is there. Now, if you look at this series, this is 3 times this series that we are interested in, right? We set out with a goal to find the sum of squares. I write Sn squares is equal to. So sum of the n natural numbers square is given by Sn square. So we'll have 3 times Sn squares. Right? This is the series we are interested in. Minus, we have 3 times the sum of the natural numbers that we did before. Okay? Right? You see 1 plus 2 plus 3 and so on. It will go till n term. And the last thing you will have, how many? 1, 2, 3. You will add 1 to n. Right? Okay, so now we know we are in business. Okay, because we did a lot of hard work and we got this formula. 3 times sum of the square of the natural numbers minus, oh, let's write just n, this one. And it was minus 3 times n into n plus 1 by 2. Right? So we have an equation. Okay, so let's solve this. So our Sn square that we were interested in, how do we find it? That will be n cube plus 3n into n plus 1 by 2 minus n. Okay, then you can already see you can take the n out. Okay, and you can take the 2 out as well. You have 2n square. Here it will become 3n square plus 3n minus 2n minus 2n. Right? So our sum of n square becomes n by 2 times 2n square. Oh, sorry. Yes, here I did one mistake. I have. Okay, I took the n out, so I have 3n and 3. Oh, yes, you're right. I have done one more mistake. I need to take n out, okay? So this is there. So effectively, okay, now it is error free, okay? So you have 2n square plus 3n plus 3 minus 2. So you have 3n plus 1. Okay, now you can split this polynomial here, 2n plus 1. Write it down in your notebook one time so that you remember forever in life. If you forget this formula, you can always derive. This is n by 2, and here this is 2n square plus 2n plus n plus 1. Right? So you take n. Here you can see there will be n plus 1. Right? And then here will be 2n plus 1. Okay, divided by. Okay, so this is clear to all of you. So this is homework. You need to find sum of the cube of the natural numbers. Okay, you have 1 cube plus you have 2 cube plus you have 3 cube and so on. You have n cube. Okay, with this technique, what we are going to do, we are going to look now. So if you want to find the sum of the cube, you take n to the power 4 minus n minus 1 to the power 4. Okay, and then you try to find this expansion, right?
Okay, sir.
And then you go for n equal to 1, n equal to 2, and further on. And then you will see something interesting, okay? So you can take this problem as a homework. I gave you a general method, and I will give you one more problem, okay? So do this for the cube. What about the sum of the power 4? Okay, so like 1, 4, 2 to the power 4, 3 to the power 4, and so on. Okay, you first do this, okay, as a homework. And then you do this as a homework. If you do these two, you never forget how to get these things. Okay. But let's look at few things. So for example, there is something called arithmetic mean. Do you know what is arithmetic mean?
Yes, sir.
Tell me.
Sir, arithmetic mean is the sum of all the terms upon total number of terms.
Indeed. And if A, B, C are in arithmetic progression, then B is the arithmetic mean of A and C. Okay, so there is a special property of arithmetic mean for arithmetic progression. If A, B, C are in AP, arithmetic progression, then this is the property. Okay. Now let's focus on some questions. I'm not giving you right now any question, but I'm giving you a strategy. If you get a question where three numbers are in AP, okay, if you get a problem where three numbers are in AP, okay, then how will you assume the terms? So when you are given a problem that three numbers are in AP, do this, do that, and so forth, you can take these three numbers as A minus B, A plus B, right? Okay.
Yes, sir.
So this will help you solve that problem very easy. You could have also done like A, A plus B, A plus 2B. Okay, you could have done this as well, but this is not a good approach. Okay, to solve, if three numbers are in AP, you do this. Okay, similarly, you can devise a strategy for if four numbers and five numbers. So you try to be symmetric. Okay, so for example, if I ask you take four numbers in AP, you have to assume, and then in the question there are many things. Okay, do this, do that, find this. Okay, then what you do is, okay, I will take A minus B, A plus D are the nearest neighbor. So you can see their difference is actually 2B. So the next term will be
A plus 3D.
exactly. And here the term will be
A minus 3D.
fantastic. Okay, so these are general techniques, and then you can go to the 5. If you go to the 5, then you can use So if you are said like there are 5 numbers, then you take the middle one as A, and then you can decrease A minus B, A minus 2B, A plus B, A plus 2B. This kind of approach reduces a lot of effort. Okay, so let's focus on geometric progression. Okay, are you people okay? Not bored?
Yes, sir.
You are all fine. Okay, so geometric progression is like the first term is A, the second term is AR, the third term is AR square, AR cube, and AR to the power N. Okay, so the RF term is, let's say, ith term, okay, because R is there, we don't want to mix the variable. Okay, so we say the ith term in this series will be A, okay, R to the power I minus 1. Right, in geometric series, if you take the ith term and divide it by, or you take I plus 1th term by ith term, it will be A R to the power I divided by A R to the power I minus 1. You can see there is always a finite ratio. Okay, so if you divide the next term by the previous term, you always get a factor R. Is this clear?
So could you please explain once more?
Okay, so geometric series is usually consisting of a sequence which is shown in the figure. A, the first term is A. I'm just giving you an example, a general series. The second term is AR. Okay, so if we take the ratio of the second term by the first term, what do we have? AR divided by A. So you get R. Right?
Yes, sir.
So in geometric progression, this is the property that the next term has a factor R more. Okay? If you take ith term, how will you define? It will be A into R to the power I minus 1, right? You can look up here. I have the first term. I have only A. So this is A times R to the power 1 minus 1, right?
Yes,
And
sir.
the second term is A into R to the power 2 minus 1 is R to the power 1.
Yes, sir.
And so on. Okay, this is how a geometric progression looks like. If somebody asks what is the rth term, you write like this. Or sorry, ith term, you write like this. Okay.
Yes,
And
sir.
every next term has this ratio. Now, if somebody asks you, what is the sum of this series? So you want to find the sum. Okay. So you have A plus AR plus AR square plus AR cube, and the life goes on like AR to the power n minus 1. Okay, now what can I do so that I can find the sum very easy? Suppose I multiply this series by R, what will happen? I get R into S. Okay, now just watch me how I'm writing the terms. I multiplied R to A and I wrote like this. My first term is this, okay? I shifted it. Okay, then I'm writing A R square, A R cube, okay? This will continue till when? Here is A R to the power n minus 1. And we will have one more term that will be A into R to the power n. Right? Do you agree with
Yes,
this?
sir. Yes, sir.
Okay, now our life is very easy. You see a pattern? Now I'm going to multiply minus 1 to the second equation. Okay, this is my first equation. And this is my second equation. Okay, you can imagine this is my second equation. I multiply minus 1 with this one and add them. So you see, if minus 1 is multiplied, this becomes minus, this becomes minus. Here comes the minus. This becomes minus, this becomes minus, this becomes minus, this becomes minus. Okay, let me take something to rub. Okay, now our life is easy, right? Just imagine I add them. Then this term and this got cancelled. This got cancelled. This got cancelled until here. Only first and the last term remain. Okay, so what I can conclude from this discussion is following: S into 1 minus R, okay, from left hand side is going to be equal to A minus AR to the power n. Right. So I can easily write my sum of this horrible series, is easy. A r to the power n minus 1 by r minus 1. Right? So I think we close our class for today with this. We'll continue day after tomorrow. And please try to do NCERT problems. Start reading whatever books you have. I will send you some PDF with some questions. Okay. Himanshu, any doubt, any question?
No, sir.
Okay. Thank you very much.